We're going to be looking at a whole lot of things that are very important, very important. We're going to be looking at distance. We're going to be looking at displacement. We're going to be looking at speed and velocity. We're going to be looking at introduction into velocity time graph. And we're going to be looking at equations of motion. Equations of motion. So grab your writing materials. It's going to be a very interesting ride. Now let's look at distance. Now what is distance? Distance is simply what? The interval between what? Between one position and the other, or difference between 2 points. For example, this is 1 point, this is another point. So you can say there is a distance of what? Of maybe 3 meters between them. So that is distance. Now when we are looking at displacement, we are looking at distance in a specific, let me use this place, displacement. We are looking at what? Distance in a specific direction. We are looking at what? Distance in what? In a specific direction. So for example, let's say we have a dot here and we have a dot here. The distance is, let's say it moves from this dot down to this dot up. Now let me analyze this so that you can easily get it. Now I would say it moves a distance of what? Of, let's say, 3 meters, but its displacement is what? Is what? 3 meters knots. So that's the difference between distance and displacement. And take note that they are units. They have the same unit, both distance and displacement. The unit of distance and displacement is what? Is meters. Unit of distance and displacement is what? Is meters. Now let's move on to speed and velocity. Now when we are looking at speed is just the time rate of what? Of change in distance. Speed, that's what? Distance over time. While velocity is the time rate of change in displacement over what? Over time. Now take note of this very important info. Speed is a what? Is a scalar quantity. Why what? Velocity is a what? Vector quantity. Now they both have what? They both have the same unit, meter per what? Meter per seconds. Now there are different types of speed and velocity. We have uniform speed, we have instantaneous speed. Now when we are looking at velocity time graph, I would clearly explain uniform speed, and let me explain instantaneous speed. Now instantaneous speed and velocity. Instantaneous speed is just talking about the speed of an object at an instant. Instantaneous speed is mostly used in what? All these speedometer, anemometer. So that's where instantaneous speed is used. And now this is the graphical representation of instantaneous speed. This is the graphical representation of instantaneous speed. So the speed at these points, let me use another ink so that you can easily grab what I'm saying. The speed at this point at this point, any point here, the speed at any point is known as what? Is known as the instantaneous speed. Is known as the instantaneous speed. So take note of that. Very what? Very important. Now, what is acceleration? Acceleration is just referring to what? The time rate of what? Of increase in velocity. Acceleration. Time rate of what? Increase in velocity. Now take note that for acceleration to occur, there has to be a what? Increase in velocity. There has to be increase what? Increase in velocity. Now what does this imply? It means that when velocity is constant, acceleration is equals to what? Is equals to 0. Take note of that. When velocity is constant, acceleration equals what? Equals 0. Now let's begin to look at scenarios that may occur with graphs. So I've entered introduction into speed and velocity time graphs, and I want you to take very important notes of this. Now let's say we have a graph like this. Take note of what I've drawn. This is displacement and this is time in seconds. Displacement in what? In meters. Now what does this imply? What does this tell us? What message does it pass across? Now what message does it pass across? The message it passes across is this. Take note of what I want to say. Velocity or speed is equal to 0. And I would explain why now. Okay, let me do it like this. Let's draw a velocity time graph. Let's draw a velocity time graph. Now let's draw a velocity time graph. Let me use a blank slide so that you'll be able to understand it very well. Now drawing a velocity time graph. Now take note of what I want to, of the points I want to draw out. The slope of a velocity time graph will give us what? Acceleration. The area will give us what? Will give us the displacement. Please take note of this. The slope of a velocity time graph will give us what? Will give us the acceleration, while the area of a velocity time graph will give us what? Will give us the displacement. Now let's analyze some things using what? Using this velocity what? Velocity time graph. Now let me make this side A. Let me use another ink. Let me make this side A, B, and what? And C. Now in slide in part A, now look at, see that there is a gradual increase. There is a gradual increase. Anywhere you see, take note of this, anywhere you see, this shows that there is a uniform what velocity. See, there is a uniform what? Uniform velocity. Anywhere velocity is uniform, it will give rise to what? A constant acceleration. Please take note of what I said. Because we have a uniform velocity here, the velocity is increasing uniformly. There will be a what? There will be constant acceleration. Please take note of that. Very, very what? Very, very important. Now let's highlight another thing again. You can see in this part that what? Velocity is constant. Anywhere we have constant velocity, what would happen? Acceleration will be equals towards 0. Take note of that. Very, very what? Very, very important. Very, very what? Very, very important. Please take note of what I'm analyzing here. Now, we can see that in this part, velocity is what? Decreasing uniformly. So what are we going to have in this place that velocity is decreasing uniformly? We would have what? Constant velocity, uniform velocity, but we would have what? Constant deceleration. So please take note of these very, very, very well, very, very important things. I've explained also here when we have a displacement time graph. I've explained here when we have a displacement time graph. What we have here is a displacement time graph. So because displacement is constant, velocity of or speed will be equals to what? Equals to 0. So if the displacement is peradventure doing what? Increasing uniformly, so if we have a uniform displacement, we are going to have what? A constant deceleration. So please take note of this. Very, very, very what? Very, very, very important. Now let's move on to the final part of this video. Equations of motion. Equations of what? Equations of motion. And this part is also very, 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 very what? Very, 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 very important. Now I'll just write the equations of motions that we have, and in the subsequent video we are going to be doing what? We are going to be solving questions on equation of motion, and also we are going to be looking into some theoretical questions on introduction to motion that we are doing now. Now we have, these are the equations of motions that we have. Now the first is what? V is equals to U plus AT. We have S is equals to UT plus half AT square. We have V square is equals to what? U square plus 2AS. Now, you might be wondering, what is the V? What is the U? What is the kinikon? What is the kinikon? Don't stress yourself. V, let me use another ink so that it will be beautiful. Now, V is equals to what? Final velocity. U is equals to what? Initial velocity. A is equals to what? Acceleration. T is equals to what? time, and s represents what? Distance. So take note of the following very important terms. In this subsequent video, we are going to be solving questions on equation of motion, and also we are going to be solving some questions on theoretical calculations that may arise under this topic. So thank you and God bless you.